Hi, this is King of Review. Solve the following system of linear equations using matrices. Then find the value of y minus x. Now if we have a system of equations, that's ax plus by equals e, and cx plus dy equals f, then we can represent this system with a matrix equation. So the first matrix is going to be the coefficient matrix. So the coefficients of our x and y terms, a, b, c, and d. In the next matrix, we put our variables, x and y. And this is equal to the constants, e and f. So let's set up an equation for this system. So again, we're going to start with our constant matrix. So we have 4, 5, 2, and 3. And then we have our variable, x and y, and this is equal to the constants, 6 and 4. Now we want to solve for x and y. What does this mean? Well, if you look at our system here, these are linear equations. That means they're the equations of two lines. So when we solve for x and y, this represents the intersection point, so the point that's in common for both of these lines. So we want to solve for x and y here. In order to do that, we want to get x and y on one side of the equation. So we need to move this one over here. One way of doing that is to take the inverse of this. Now some matrices do not have an inverse. You can tell if a matrix has an inverse by evaluating its determinant. If the determinant equals 0, then it does not have an inverse. So how do you find the determinant? Well, if we look at this one here, the determinant is the product of the entries in the main diagonal minus the product of the entries in the other diagonal. So we have a times d minus c times b. Now, if this is equal to 0, then the matrix does not have an inverse. But if it's not equal to 0, which is what we want here, then it does have an inverse. So let's check. So here, first we take the main diagonal, 4 times 3, and then we'll subtract the entries in the other diagonal. So we'll subtract the product of the entries. So 2 times 5. So we have 12 minus 10, and that equals 2. 2 is not equal to 0, so we know that this does have an inverse. So we know that xy, matrix xy, is equal to the inverse, so we represent that with the -1, the inverse of this matrix times the constant matrix, 6, 4. So how do we find the inverse? Well, if we have matrix A, let's say matrix A is A, B, C, D. The inverse of A, so A inverse, this is equal to 1 over the determinant, and the determinant, we already solved for that. That's here, we solved for that. You use this equation. So it's 1 over the determinant times the matrix that has the entries. Well, A and D switch places, so we have D up here and A here, and then we take -b and -c. So let's figure out what the inverse of this is. So we have 1 over 2 because we solved for the determinant here, and now we know that 4 and 3 switch places, so we have a 3 and 4, and then -5 and -2. And we're still multiplying this by the matrix that has the constants in it. So now let's multiply these matrices together. So we're going to do 3 times 6. So 3 times 6 plus negative 5 times 4. And that equals negative 2. And next we do negative 2 times 6 plus 4 times 4. And that gives us a 4. So now we want to multiply each of these entries by 1/2. So 1/2 times negative 2, that gives us negative 1. And 1/2 times 4, well, that's a 2. And this is equal to the matrix with x and y. So now we know that x is equal to negative 1 and y is equal to 2. Again, we want to find y minus x. So we have 2 minus a negative 1, which is 2 plus 1, and this equals 3. So 3 is the final answer. Thanks for watching.